Hello, everyone. Good morning, good afternoon, wherever you are in the world. Thank you for joining our webinar today. I'm Thomas von Larcher. I'm managing editor of the journal, and I help to run the meeting today. So today we have Professor Angelo Beltran with us from Adamson University in Philippines. Professor Beltran received the PhD in electronics engineering at Mapua University, Philippines. He is currently working at the Department of Electronics Engineering at Adamson University, Philippines. Between 2015 and 17, he was a visiting scholar at the Department of Electrical Engineering at Zhonghuan Christian University in Taiwan. He is a professional electronics engineer and a former research and development engineer for power electronics and motor control in Servotech in Taiwan. And I should not forget to mention that Professor Beltran is a member of the editorial board engineering of the journal SN Applied Sciences. So coming back to the talk today, we will have time for questions after the talk. So please feel free to type your question into the chat box as we go, or after the talk, you can unmute yourself and ask your question. So with this, I hand it over to Professor Beltran. Angelo, welcome to our webinar today. We are very happy and delighted to have you in our webinar series, and the floor is yours.
Thank you, our dear managing editor, Thomas. So I'm about to present my presentation now. So my talk for today is all about fuzzy logic based maximum power point tracking using Opal RT real-time machine for solar PV system. And the context of renewable energy is very much wide, but our focus for today's topic will just be on solar PV system in conjunction with the maximum power point tracking. And the maximum power point tracking is a very good investment for a solar PV because it will enhance and improve the efficiency of the overall solar PV system. So again, my name is Dr. Angelo Beltran Jr. I am from Adamson University. And I would like to thank our managing editor, Thomas, for inviting me for today's presentation. And the outline of my presentation are as follows. So before we proceed with the maximum power point tracking, I will give some introduction about solar PV as well as renewable energy, and then followed by fuzzy logic. And then, of course, I will give a small preview about the Opal RT e-megasim machine, and then discuss some of my details of my design related with the maximum power point tracking of fuzzy logic, followed by results, and then conclusion. So as an introduction, well, we all know that most of our energy resources do come from fossil fuels. So when we say fossil fuels, these are composed normally of oil, gas, coal, and of course, some nuclear power. And with the usage of these fossil fuels, climate change, greenhouse gas emissions, and global warming do attributes to the effects of this burning of fossil fuels. Therefore, it produces pollution such as air pollution, land pollution, as well as water pollution. And that is why efforts from different countries are doing some relative solutions, sustainable and renewable solutions without impairing our environment. And that is why in recent years, there has been a positive increase of research related with renewable energy, not only for solar, but also with other kinds of renewable energy, such as wind energy, biomass energy, hydrogen or hydro power energy, and so on and so forth. And this particular research should address long-term energy solution. And of course, it must not impair our environment. And renewable energy is composed of these following: no? Wind, geothermal. In the Philippines, in the case of Philippines, we have a lot of geothermal energy because we are residing under the Pacific Ring of Fire. And we have a lot of volcanoes. And the positive side for that would be we can invest a lot of geothermal energy. And solar, and then hydro energy, and then of course biomass energy. Non-renewable energy are composed of coal, burning of natural gas, and then nuclear is also part of the non-renewable energy because it can impair our environment, and there is some safety issues. Speaking of renewable energy, the focus of my talk will be all about solar PV. And solar energy, in the case of Philippines, there are a lot of projects that is currently doing right now by government, by private industries, and several universities here in the Philippines, as well as military research, transportation, and space program related with the usage of solar energy. And one advantage for that is the source is clean and abundant. Of course, it is solar, promising, and its energy never ceases. And in the case of Philippines, solar energy is one of the renewable systems that attracts attentions of many researchers in recent years as well as in recent decades. The demand of solar energy are increasing yearly because, again, it is clean and it is a renewable source of energy. So one of the most important problems that we should address with solar PV is the increasing of the efficiency of solar, of which I'm going to discuss it later. No? And with due respect with the solar energy, here are some of the advantages of using solar energy. So the first one, the energy conversion is very simple. We convert the light into electricity through the use of a simple solid state devices. And the most common ingredient of manufacturing of solar PV is silicon. Silicon is one of the most abundant materials in the globe. Another advantage is the absence of mechanical noise from moving parts. Unlike with the wind energy, there is a movable parts there because it is using motors as well as generators to produce energy, which therefore causes some mechanical noise. Maintenance cost is low, easy to operate, and lack of greenhouse gas emissions, of course, and they do not create pollution. And with the advent of latest solar PV system, nowadays a solar PV can at least have an economic life of around 20 up to 25 years. High reliability and high power to weight ratio, which is therefore very applicable for roof loading. Here in the Philippines, we have a lot of researchers as well as clients that they want to install solar PV on their rooftop. And of course, in space application, wherein the main source of energy for space satellite communications are solar. Now, if we have some advantages of solar energy, there is also what we call the demerits or disadvantages of solar energy. And initially, when you want to install a solar PV, the cost of installation is very high. You need to invest some money, yeah, or you need to spend some money to install a solar PV on your rooftop. And since solar PV is only applicable at day, where the sunlight is present, battery is needed at night because sun is not available. And the focus of my talk will be the efficiency, because right now the efficiency of solar PV is quite low, although it is acceptable, but it's still quite low. And aside from it is dependent on weather, whether there is a cloud, and the response of a energy or the solar power output that has been produced by the solar PV is quite low. And this is the reason why maximum power point tracking need to be addressed, because the efficiency of solar energy is quite low. Now, there are two general methods to increase our efficiency of a solar PV. The first one was to use the so-called sun tracker, wherein you need to put some mechanical track on the solar PV such that whatever will be the orientation of sun, it will also follow the solar PV. And the second method is the so-called MPP tracker. This MPP tracker, you don't need to orient your solar PV to tilt to follow the orientation of the sun, but rather the control system will be the one to adjust in order to increase or even to decrease the power output that can be produced by a solar PV. So let's talk something about definition of maximum power point. A point in the nonlinear PV and the IV characteristic curve where the maximum power exists. Later, I will be showing the so-called PV curve and IV curve. As the conditions of weather and atmosphere are changing, and these important parameters are temperature as well as the intensity of radiation, they are changing as time passes by. Therefore, the location of the MPP is also changing. That is nonlinear. And since the location of maximum power point is changing, if you try to use a traditional method for locating the MPP, then sometimes it's not still quite efficient. And this is why we need to address some other method to locate the maximum power point. And this is where the fuzzy logic will enter on the scenario. So graphically speaking, this is the power characteristic curve of the solar PV. So the maximum power point exists between these two areas. So this is our maximum power point. And when we check our power versus voltage characteristic curve, this is where it lies, the maximum power. This particular characteristic curve is a current versus voltage. But when we want to plot the power versus voltage, then this is our corresponding plot. And from time to time, as the location of the maximum power point changing because of the changing conditions of weather, then sometimes the point exists on this part and sometimes on this part. And so therefore, it complicates the tracking of maximum power point. So when the derivative of power with respect to voltage is greater than 0, then we expect that the power point exists here. If it is less than 0, then it locates or it is around here. If it is equal to 0, then it will be here, which means that we have located the maximum power point. And that is the correct time to harvest the maximum power energy. So maximum power point is different from maximum power point tracking. And technically, when we say maximum power point tracking, it involves associated hardware and software that real-time interactly communicate with the DC to DC converter in order to adjust continuously the DC operating point. And the purpose of doing so is to harvest the maximal available power that can possibly produce by solar PV. So again, when we say maximum power point tracking, it distinguishes from mechanical tracking because we are talking about electrical tracking in this case. So graphically speaking, or should I say mathematically speaking, what we want is to determine first the two inputs of the maximum power point tracker. So we have the derivative of error with respect, or should I say derivative of power with respect to voltage. And also the second input will be the change of error. So basically you need to compute first the error before you are about to compute the change of error. Because mathematically speaking, the change of error is the difference between error and then error k minus 1, which means time lag of at least -1. And then the output of the maximum power point tracking is actually a duty cycle. And that duty cycle can be computed by this particular formula. This formula was actually obtained from fuzzy logic systems. And that would be the summation of mu d minus d all over the summation of this particular mu and d, wherein d is the duty cycle of your system. And when we try to apply fuzzy logic with maximum power point tracking, this is the overall picture. So first we need two inputs, and these are the error and then the change of error. And then this particular input will be falsified by fuzzy logic before it proceeds to the inference engine, and then it will be defalsified later on. But do take note that the fuzzy logic also composes some fuzzy rules, or what we call the fuzzy sets. Based on my experience as a designer, these fuzzy rules should be tuned, because if you don't tune properly your fuzzy rules, then it will not produce a good output on your maximum power point tracking. So you need to trial, or you need to apply some optimization algorithms in order to tune properly the fuzzy set rules. So we have the falsification, we have the inference engine, and then we have the defalsification, where y of k will be your corresponding duty cycle. Now, when we try to apply that on a general perspective, so this is my design actually. We have two inputs on maximum power point tracking. We have E of n and then delta E of n. And then we have three scaling factors for the fuzzy logic, denoted as K1, K2, and then K3, followed by a PWM generator. And this PWM generator will be fed by the output of fuzzy logic as well as the three different scaling factors before it proceeds to the boost converter. Of course, DC to DC converter can be categorized into several options. You could use buck converter, you could use boost converter, or even buck boost converter. It's up to you as a designer, or which particular converter should you use. But on this particular design, we have used a DC to DC boost converter. So just for the sake of presentation, we have used a resistive load in this case to illustrate the importance of maximum power point tracking. And yeah, this is the illustration of the maximum power point tracking. I already discussed this one. Maybe we could skip this. Okay, so let's talk something about the machine, because this was the machine that I have used in my design, the so-called E-Megasim. E-Megasim is actually the part number, or should I say the brand of the machine. And Opal RT is the name of the company. You could use Google search for Opal RT. And Opal RT is one of the major manufacturer and distributor of this real-time machine. Just some preview about the specifications. We have the RTLab version 11. This RTLab is actually a software. And we also have some advanced monitoring capability, scalable I/O, and the corresponding operating system that has been used by the E-Megasim is the Red Hat Linux. And this machine is composed of high-powered Intel Core processors. Embedded also is a Xilinx development board if you want to use FPGA inside. And there are some functions that you can use to produce analog or even digital signals, to analyze signals such as resolver if you're doing some motor control or PWM. And of course, 32 IO, ADC, and DAC signals. All right, so this is my design on my fuzzy logic MPPT. Actually, this is just a simple block diagram, but inside of that particular block diagram, they have a specific complex design. But for the sake of presentation, let me just present it in a very simple way. Just illustrate the MPPT design. Here we have a mother. The master is MPPT. And then the slaves in this case is the solar PV. You develop a PV model on your design and your DC boost converter. And then this particular console will measure the different parameters on your design, such as power or output voltage or even output current. And you also measure the response of the PWM duty scale during operations. Okay, so we have the host PC. The offline simulation average is around 20.88 seconds. And there is a big difference, almost half, of around 10.38 seconds. So this is a very big advantage of the Opal RT machine. Because when we are using Opal RT machine, whatever will be the response of that particular machine will also be the same response for the experimental setup when we set up the corresponding system with the actual on the rooftop solar PV. So just a conclusion, we have implemented, of course, the fuzzy logic and perturb and observe models to our E-Megasim using the RTLab software and MATLAB to check the performance of both MPPT system. And it has been shown that the presented technique has been better in tracking achievement of MPPT and obtain maximum power in terms of variable temperature and solar insolation conditions preferred with conventional setup. And the performance of the MPPT is presented with the offline result altogether with the real-time results. And the future effort of our research team is currently directed to implementation of fuzzy logic on a chip, particularly in FPGA. And we could be able to use it by means, or we could be able to test it by means of hardware in the loop structure. Okay, so that's all my presentation. Thank you.
Yeah, thanks a lot, Angelo, for this very nice presentation. Um, Unfortunately, I was offline for 4 minutes, so I can't see any questions in the chat box up to now. So if you typed into the chat box your question, so please unmute yourself now and ask your question.
Okay. There is a one question here by El Mustafa Shetouani. Correct me if I'm wrong. And the question was, is it possible to use a inverter, no, in the situation of alternative load? Mr. El Mustafa, yes, that is possible. You could use a inverter as an alternative with the load. But for the sake of my presentation a while ago, we have just used a resistive load to compare the performance of fuzzy logic and perturb and observe algorithm. But if you want to extend it with the use of DC to AC converter to change your load, because right now I'm presenting a DC load, then you can do so. That's possible. So that is my answer, Mr. El Mustafa.
Okay, thank you. Are there any other questions?
Right now, there is no more question. Let me see. Okay, so thank you for outstanding. Thank you to Mr. El Mustafa. So which is the switch that you use for DC to DC converter? Which is the switch? Just a MPPT direct with the DC to DC converter, Mr. El Mustafa. I have not used a particular switch, but if we go back to my presentation, we have used a PWM, pulse width modulation converter, to switch the DC to DC converter. And we could use a MOSFET as a switch for the DC to DC converter. What steps are required to step up the time scale to use the concept in a PV park application? Steps required to use the concept of a PV park application. In the case of real-time simulation, the scale is around the 16 volt positive and 16 volt negative. But if you want to perform an actual setup for solar PV, you could actually design your own positive time scale step for the concept of a PV for a solar PV park. That depends on the specification sheets of the MPPT or even the solar PV system. Yeah.
Okay, thank you.
Yeah, because Mr. Christoph, no, the presentation is real-time simulation with Opal RT. And you know, when you try to set up an actual solar PV and actual maximum power point tracking, maybe the results would differ with the results that I have presented. And that is why you need to check first of all, the data sheets and the specifications of your MPPT and solar before you actually apply it on your solar PV, especially if you're developing a solar farm power system, solar PV power system for a solar farm, because that is a very large scale integration. But for a rooftop installation, maybe you could just use a small scale or not so very powerful MPPT data sheets or even specifications. Yeah.
Okay. Thank you, Angelo. So, don't see more questions. All right, then we will close this session.
Okay.
Thank you very much for attending our webinar. Thank you, Professor Beltran, Junior, for this very nice presentation. And yeah, to all, have a good day or a good afternoon, wherever you are in the world. Goodbye, see you next time. Bye-bye.
Bye. Thank you.